Hi students, in this video we will be going over rate of change. Our essential question for today is, what is rate of change and how is it calculated? So once again, our essential question for today is, what is rate of change and how is it calculated? So first, let's think back to slope. And you've got some problems on the foldable that you have for this set of notes, and you have 4 problems on that first tab that are a review of slope. So I want you to take a few minutes right now and practice those 4 problems and then submit your answers. Okay, so today we're going to start off by talking about unit rates. Now, a unit rate is a rate in which the second quantity is in the comparison is 1 unit. So you're comparing a quantity to another quantity. So for instance, think about when you drive. You have miles per gallon. So you're talking about how many miles can you drive per that 1 gallon. Or if I'm talking about purchasing something at the store, I might spend $6 per, maybe it's gallon again, or maybe it's whatever that unit rate is. So in other words, a unit rate in math is a ratio, and a ratio is a fraction that compares 2 units. And that second unit, which is the denominator, is always the number 1. All right, so example number 1, we've got 120 bottles in 6 cases. Now what we want to do is we want to write this as a ratio and get it into a unit rate where we're comparing the bottles to 1 case. So all I do is I write this as a fraction. It's 120 bottles over 6 cases. And to get that in a unit rate, think about that. If I wanted to get the denominator to be 1, so I wanted just 1 case, I would divide it by 6. And whatever I do to the denominator, I also need to do to the numerator. So I'm going to reduce it by 6. And when I do that, I get 20 bottles over 1 case. So that means in each case, there are 20 bottles. And to write this as a unit rate, you would just write it as 20 bottles per case. Another example would be if we were paying $84 for 4 books. To write this as a ratio, again, you just put 84 over the 4 books. And we want to get those 4 books to be 1 book. We want to know what is the cost for just 1 book. We know what it is for 4, but what is it for 1? So if we want to get that denominator to be 1 book, then I need to divide it by itself so it becomes 1. And whatever I do to the denominator, I must do to the numerator. So I'm going to divide both the denominator and the numerator by 4, or we're just reducing it. And that would give us $21 per 1 book. So that tells us that the cost per book is $21. Now, one thing that I probably should have made note of, and if you took your notes in this, I do apologize, but there is a little box up here that says foldable, because you can put some of these examples in your foldable as well, okay? Now, one thing that I want to make note of that you'll see here at the very bottom of the page, it says not all unit rates will be even. Sometimes the answer might be a decimal. So for instance, if I had said that instead of 120 bottles per case, it was 124 bottles, which doesn't really make sense in this example, we could see that when you divided the numerator and denominator by 6, you would get a decimal. So that is very important to note that in these examples that I showed you, they are even, but that is not necessarily the case. All right, you've got 2 practice problems that are on your foldable. Take a second, try these out, and submit your answers. Okay, another way that you can look at unit rates is in a graph. And when you look at this, again, you're trying to make a ratio to compare 2 things. So in this example here, we've got time and we've got distance. So we've got time over here and we've got distance over there. Now what you want to do is you want to find a place where both of, basically where the line, okay, your slope that you have is going through at a perfectly even point. That way you can tell what it is. And if I look right here, I can go, okay, so if I follow the 1 up, it crosses right here evenly with the 50. So I'm going to see if I can draw that in. Sorry, this pen is, there we go. So I can see that this 1 and the 50 meet perfectly right here. Okay, and that's really helpful because when we make our ratio, what we can see is that that is telling me that that's 50 miles per 1 hour. And then if we were to follow that up, we can see that it goes and it becomes 100 miles per 2 hours, okay, or 150 miles per 3 hours. So it increases at a constant rate. And so all you're looking for is that point where they evenly meet on the graph to say that it's at a certain rate. Now, in this case, we didn't need to reduce it, so our answer would simply be 50 miles per hour. Now, let's look at this other one and see if it's a little bit different. Now, this one is pretty similar as well, but let's say I didn't see this 1 right here, okay? You could also, there's several points where you could meet. You could follow the 2 up all the way to the 6, and that tells you 6 books read per 2 weeks, okay? But in this case, again, this pen is terrible. We can also see at the 1 that it also has 3, okay? So if 3 and 1 meet evenly right there. I'm having a hard time drawing this. Okay, so that's really terrible drawing. But as you can see, they meet evenly right here, okay? And that tells us that the ratio then is going to be 3 books read over a 1 week period. So that just means 3 books per week. Now, another thing to note is that some of the problems that you're going to see as examples, they're not always going to work out perfectly with 1. You might have to look at one that is at 2 or 4 or 5 and then reduce that ratio, okay? All right, so you've got a couple practice problems to try out. I do want you to make you aware that what I just mentioned, that may not be perfectly even. You need to make sure that you reduce your answers to be 1 unit rate. So try those examples and submit them on Edpuzzle. Okay, so now let's talk about rate of change. And rate of change is a rate that describes how one quantity changes in relation to another quantity. So once again, it is a rate that describes how one quantity changes in relation to another quantity. Now, just like slope, you can have different rates of change. You can have a positive rate of change. Think about those graphs we were looking at earlier when it was saying 3 books read per week or something like that. That would be a positive rate of change. Every time you read a book, each week, the weeks are increasing and the books are increasing. Now, a negative rate of change means that something is decreasing. Maybe an example could be the amount of gas you have in the car compared to the time you have driven. So the farther you drive, the less gas you have, or the longer you drive, the less gas you have. So that's a negative rate of change. And a 0 rate of change is very simple. It just means that there is absolutely no change happening on the graph. There is no rate of change, so it's just 0. Now, one thing to remember on this is basically the positive saying that when the value of x increases, y increases. On negative, it's saying that when x increases, the y decreases. And on the 0, it's saying as the value of x increases, the y remains constant. Nothing changes. Now, the slope of a line is a rate of change. Think about the slope from the last lesson, and basically, slope and rate of change are the same idea, just different words. Usually when people think of slope, they think of just those very specific problems that they have with graphs or where they're finding the slope based upon certain numbers, but it's the same thing as rate of change. Rate of change, we just tend to talk more about those real life scenarios where there is a change occurring in some sort of real life problem. But the rules are the same for rate of change as they are for slope. It is the vertical change, so the y, the change in y, over the horizontal change, which is the change in x. And it's the same thing as rise over run, which is the same thing as finding the difference in the y's over the difference in the x's. So it's all the same. So one thing to remember through all this is that the slope of a line and the rate of change are the same. Now let's look at a couple rate of change problems. In this problem it says, each year Avid goes on a field trip to Knott's Berry Farm. The cost of the field trip for the past 5 years is listed in the table. According to the table, what was the rate of change between 2014 and 2016? Now, since they're talking about two specific dates, you're only going to focus on those dates. Okay, so you're going to focus on the date 2014 and 2016. None of those other dates, okay? And when you look at the table, this is your x values and this is your y values. And when you think of slope, which is the same as rate of change, you just know that you're going to subtract your y's and then you're going to subtract your x's to create some sort of ratio. Okay, and so this very simply will look like this. And where we are having the y's, 34 minus 22, which is our y's, and then we're subtracting our x's. So 2016 to 2014. Remember, this is the dollars per the years. Now what this is saying so far is that there was a change of $12 per 2 years. Now this is a positive change. It was an increase. Sometimes you'll see problems that are negative and might have a decrease in the rate of change. But overall, what this is saying is that that had a $6 per year increase. So that was the rate of change between that 2-year period. Okay, let's look at another couple examples. Now there are different types of rate of change. There are constant rate of change, there's variable rates of change, and there are no rates of change. Now on the constant rate of change, this is talking about when the x is increasing, the y is also increasing. And you can see it's a straight line. It's not detouring from that. It's not becoming anything different. That is a constant and simple increase and rate of change. Now a variable rate of change, it says that as the value of x increases, the y can increase or it can decrease. So if you look at this graph, it increases, then decreases, increases, decreases, and then finally ends by increasing. This is variable. It means it is not constant. Another way that you might also want to describe this is that this is called linear, okay, because it makes a straight line, whereas this would be nonlinear. So as it is in math, you know that there's a million names for all sorts of things that are referring to the same thing. But this would be a linear versus nonlinear, so a constant and a variable. Now, obviously, the no rate of change means that as x increases, the y is not changing at all. So nothing is really changing in the rate of change. So let's look at a couple examples. Is the rate of change constant or variable? Now to do this, again, think about creating a ratio. And you've got your x and your y value. And it really doesn't matter which way you think of it in this. We're just simply talking about ratios right now. So it doesn't necessarily mean that the x needs to be in the numerator or denominator, but you want to think about, is this rate of change constant or is it variable? So what you can do is you can just simply make some fractions out of these. So if I look at this first one, that makes 12 over 1. Well, on this one, this is going to become 24 over 2, which reduces to 12 over 1. 48 over 4, which reduces to 12 over 1. And so on and so forth. As you can see, this is constant. This is the same number, so this tells us that this is a constant rate of change. Now over here, it's a slightly different problem. It's 12 over 1, but 38 over 3 doesn't reduce anymore. And 90 over 7 doesn't either. 108 over 8 would reduce to 27 over 2. But are these fractions constant? Are these ratios constant? And since they are not, that tells us that this is a variable rate of change. All right, you've got a couple examples here to try, and you've got 3, 4, and then also complete number 5 as well. Input those answers into Edpuzzle, and then you are done. That's all. If you have any questions, let me know.